In this video, we will write a program for trees using C++. Now, for creating a tree, we require a data structure that is queue. We have already done that in a C language program. So here in C++ program also, we will use a queue for creating a tree. And in this program, I will not be writing the code once again, but I will be copying the code from C language program, which we have already seen. Because the procedure inside the function will be same, only the thing is we have to write a C++ class for a tree. So I will copy this code for queue. This is a class for queue which we have already implemented in previous videos. I will use this class in my new project. So I'll copy this one. Let us start a new project. I'll call the project name as tree CPP and let us select the language type as C++. Project is ready. Now here in the project, I will insert a new file. So I will say new file and let it be a header file. In this header file, I'll keep a class for queue. Header file, let us call it as queue.cpp. And this header file, I'll paste the code that I have copied there. So this is a class for queue. Yeah. Here, this class is using still printf and scanf because I did not change them to scene and cout. So this class needs stdio.h. So I will include stdio.h hash include. Now this queue class should be using a node for a tree. So I will define a class for node here itself. Class for node. I'm saying node. This node will be for a tree. So this node will have 3 members. So I'll make those members as public so that I can easily access them. First is a pointer to a left child. And next is data that I want to store, and third one is a pointer to a right child, so our child. Now this class is for node, so this is a node of a tree. Now this queue should work upon node, so I should modify the code for this node because I may be storing the addresses of the nodes in a queue while creating a tree. So here I will make changes. This array should be of type node pointer. So node pointer. So already it's a pointer, so double pointer. Then here inside the constructor, when I am creating an array, I should not say int, I should say node pointer. And one more place I have mentioned this is a node pointer. This queue class should store the addresses of a tree, so that's why I am converting into node. Enqueue, it should not take an integer but a node pointer. Here also enqueue, I should change it. So I'm making required changes, and dequeue should return a node pointer. In dequeue, return type is node pointer. And this variable where I am taking the data, it should be of node type and I should initialize it to null. This display function, though I don't need it, let it be, I'll just leave it. I don't have to make any changes in this function. So that's all, I guess. These are the changes what we need in a queue class. So we have made required changes. Now let us go back to the main part of a program, that is main function. So here I should write a class for tree, class for tree. Now inside this, I should have only one data member, that is root, pointer to a root node, that is root. Now the question is, shall I make it as a public or private? I may be using it from outside the class also. I suggest this should be made as public. If it is made as a private, then I have to make a lot of changes in the code. So let us declare it as public. Now inside this, the first thing is constructor. So constructor class name is tree and non-parameter is constructor, and just I have to initialize it to null. Root is initialized as null. Then no need of any constructors. Now I will write down the required methods. First one is create tree function, which doesn't take any parameter because root is available inside tree class itself. Then next function is preorder. I'll take capital P, and it needs a root pointer. So let us call it as P, pointer P, void post order, and it also takes a pointer to a root, that is, let us call it as P. Then in order, take the pointer as P. These functions we have already written in a C language program, so the same set of function I am making them as member functions of a tree class. Then also I will write on one function for level order function, and it also takes a pointer to root, and height function, height, which takes a pointer to root. That's all. These are the functions I am going to implement them outside. But as I said that I will not be writing the code once again. I will not be typing the code once again. All these functions, I'll copy them from my C language program and I'll paste them and use them here. So let us first bring the function that is create a tree function. So already I have that project open here. So this create a tree function, I'll copy it. First function I will copy it and I will use it here. And also I will make all required changes. So just watch how I am making changes in this one. This is tree create function. Actually I am calling it as create a tree. Okay, I'll change the name. This is inside tree class and this is create tree function. Okay. Then inside this is not a structure node, so just a node. I need temporary pointers. Then Q, already a class is available, so I have to create an object of Q. So yes, Q object will be created. For this one, here on the top, I should include header file, that is include Q cpp.h. This is the header file. Now I can use that Q. So if you see this header file, this qcpp.h, this header file where I have the queue as well as the node structure for a tree is defined here. All those things I'll be able to use them in my main part of a program when I have included this header file. Now line by line, let me continue. Here I was creating a queue of size 100, so instead of calling a function create, I will just call parameters constructor of queue class, so a queue of size 100 will be created. And it will be a queue of pointers of type tree node. Then here this goes regular, and here instead of saying malloc and size of all those things, I have to simply say new node. So I'll replace this with a code that is new node, and rest of the things are as it is. Then enqueue. So this is a part of queue now, queue.enqueue, and I don't have to pass this as parameter, just a root as parameter. See, this is a function, enqueue is a function inside the class, so queue.enqueue I have to say. And here, while not is empty, oh, I have not implemented is empty function, so I will be implementing that is empty function there. I'll do it afterwards. Is empty function inside a queue class. Then queue.dequeue I should say, I should not pass this anything as a parameter. Then printf, let it be as it is, no problem. Printf and scanf will be using as it is. I will not change them. So for that I should include stdio.h. I can use printf and scanf. So this is printing and reading the value, and the value is so and so. And if the value is -1, then don't insert anything. If it is not equal to -1, then create a new node. So for this, I will call it as new node. Then node is created, all the links are set. Then call queue.enqueue, change this one. Now again printf scanf, everything is as it is. Then this part should change, that is new node. And again here q dot enqueue, remove this q as parameter. That's all. This function is ready. Tree create function is ready. One thing I have to write down is empty function, so I'll go to this class and here I will introduce a function that is empty just after dequeue. This should return true or false, is empty, true or false. So for what is the condition for queue empty? If front is equals to rear, then queue is empty. It should return the result of this condition directly. Return front is equals to rear. If front is equals to rear, it returns empty. Yes, true. So this is sufficient. So I have implemented it as an inline function that is within a class itself. Now coming back to the program, see here I have implemented create function. Then I need pre-order, post-order, in-order. So I will copy those functions and I'll modify them here according to my CPP program. So here I have those functions, pre-order, in-order and post-order. So I'll copy all these functions. Yeah, here inside the main part of a program, after tree create function, I will write down those functions. All these three functions, I need them. Pre-order. This is the part of a tree. Just now have declared it here inside a class, right? Pre-order, right? Same function. I'm writing it as a part of a class, so I am using scope resolution. Then what is the change inside this? Just printf. Instead of printf, I can use a cout. Let it be printf only, so there is no difference. So just it has become a part of a tree class now. Then in order also I made it as a part of tree class. Then pre-order, post-order also I made it as a part of tree class. No more changes at all. See, as it is, the code is useful. Now it was earlier in a C program, it was an independent function, but now it has become a part of tree class. That is the difference here. Let us bring other functions, that is level order function and height function. There's a level order function. Count and height is also there. So I'll copy these and paste them here. So count I have not declared. I'm not using it. I'll remove this one. Then height and level order. Now for height, directly I will change this one. This is height, capital H I have taken, and this is a part of tree class. So just say tree, and here inside this also, this is capital H and capital H. That's all, no more changes. Same code will work for this class also. Now let us come to level order. For level order, I should call it as a member of tree, so scope resolution. Then here inside this, again a level order function uses a queue. So I have to use that queue class, this class which we have written here inside the header file. This class I have to use. So for making use of this one, I should make required changes. First of all, I'll take a queue, that is a object of queue class, and I will take it as a constructor as 100. So I will remove this one. I will not have create function. Then printf is there. Let the printf be as it is. Then this is enqueue function that was in C language, which was taking queue as well as the value to be inserted. But now it will be a part of queue class, queue object. So say queue dot and root, no need of any parameter. Then this is queue dot is empty. Don't pass it as parameter. Then queue dot dequeue is there. So queue dot dequeue. Then L child, R child. Then this is queue dot enqueue and no need of this parameter. And here also queue dot enqueue, no need of queue as parameter. That's all. Now main function I have to write afterwards, but till here let us compile and check. Are there any errors? If there are any errors, I will remove them. See, the approach what I have taken here is I have copied the existing code and I have prepared a class for tree without writing even a single line from the scratch. So only the class I have written and I have implemented all the things that are borrowed from the existing code. So I may get errors. So just watch if there are any errors, how to remove them. I'll compile this one. Yes, there are 4 errors. First one, level order. See, it is not matching here. See, inside this class I have given small letter O. This is capital letter O. Okay, I will change it to small letter O. Let me compile once again and see how many errors I get. Okay, still 3 errors. Now coming to this height. Okay, for height I got an error. So height, actually it is returning integer type. So it is giving an error that return type of outline function is different. So let us go back to the class definition and see. Oh, height I have written it as void. So it should be an integer. It will be returning an height. I'll compile it once again. Yeah, it's successful. Now I will write on a main function. Inside a main function, let us create a tree and call traversal functions. So tree t. T is a tree. Now on tree, I will call function create tree. Let us check the function. Yes, create a tree. This function I am calling, which will create a tree. Then after this, I will call just pre-order function. Now to this pre-order, I should pass a root because it's a recursive function. Definitely it needs some parameter. It cannot be without parameter. So I should pass t dot root. T dot root. Root is a data member of a class tree. Yes, there's a data member. Can I access this? Yes, it is kept in public. That is the reason I have made it as public, so that I can access it directly. Otherwise, I cannot write recursive function directly. I need some dummy functions which will call these functions indirectly. I'll show you that one. If I don't make it as a public, then I cannot call these functions that are recursive function directly. For them, I need some other dummy functions. I will show you how to do that. Later, I'll show you how to make this as private. So let us go to this main function and complete it. Yes, I am calling pre-order. Now let us run the program and see. I will create a tree and it should perform pre-order upon it. Yes, program is running. It's asking the root value. Root value I will enter it as a 10. Now left child of 10 is 20, right child of 10 is 30, and there are no more children. Yes, I got a pre-order. 10, 20, 30 is a pre-order. It's working. Let us perform in order also and check. T dot root, I will pass it as parameter. Now run it. The program is running. It's asking for the root value is a 10 and the left child is 20, right child is 30, and no more children beyond this. Yes, this is the pre-order. 10, 20, 30 is the pre-order and 20, 10, 30 is in order. So let us make it properly. Let me give a proper labeling here. Before this pre-order, I will give a message that is this is pre-order with a gap. Then after pre-order also I will give a new line and L. Then after this I will say in order, then with a gap. Then after in order again I will give a new line C out and L, that is new line, one more new line. Yes. Then when I am using C out here, I should use using namespaces. I should declare in the beginning. Already I have done it. Let us run the program. Now enter the values. Root value is 10 and its left child is 20, right child is 30 and no more children. Here you can read it. That is pre-order is 10, 20 and 30 and in order is 20, 10 and 30. Yes, it's working. That's all. Now, as I said that I can even make this root as private so that it's accessible only inside the class. Then how to write this recursive function, how we can pass the parameter. So for this, I should have one more pre-order function that is without parameter, and it should call this pre-order function by passing root as a parameter. Now let us call this function pre-order function. So you can see that this is a non-parameterized function and this is parameterized. So these are overloaded function. So from this function I am calling second one, this function, by passing a root. So from the main function I cannot pass root, so I will call this function and this will call a recursive function by passing root. So let us call this pre-order function from here and check. I am not passing root as parameter. Now let us run. It will work. Yes, it is working. So if I give the values 10, 20 and 30, then -1, -1, -1, -1, it's working. Pre-order is executed. So the same function has executed. So if you check here, I am calling the first function that is without any parameters, and that function is calling a function with parameters. So in the same way, for all these functions, I should provide a dummy function which without taking any parameters. Then I can make this root as private. So I will write down all those and I will show you finally. Yes, I have written a dummy function for each and every recursive function. So these dummy functions are calling those recursive function internally. I can make this as private now. This root, I can make it as private. So I'll just declare it above public, so it becomes a private. Now from here, I don't have to call function by passing root. Directly I can call the function. A dummy function will be called. That in turn will call a function that is recursive function. So for all of them I have given dummy functions. Now I am able to make it as private. This is the approach you have to take. If I run, it runs successfully. I'll not give the values now, already we have seen it. So that's all in this program. Oh, there is some warning, it is showing some warning. Let us check the warning. Okay, here it is giving a format specifier error. Yeah, we are displaying addresses here, but it is a D is written here. Anyway, this is a display function. We are not using it. We don't need it. So let us ignore it. That's all in this program. So you have seen how we can write a C++ class for a tree. So you can write on this by yourself. If you have implemented those functions, you can borrow them here and you can avoid typing the whole program once again. So that is the reason I am having printf, scanf as it is used here. You can change them to cin and cout also. So that's all in this video.